Hi, welcome to this edition of Ask the Expert. Today we're going to be talking about PLCs, or more specifically, PLC Next from Phoenix Contact. Today we've got Tony Dean from Phoenix Contact and Pete Wood from DesignSpark. Hi guys, would you like to introduce yourselves?
Hey Greg, Greg, I'm Pete Wood. I've got an electronics background and single board computers. So I'm quite excited to find out today from Tony about these PLC things that he's been telling us all about recently. So yeah, over to you, Tony.
Yeah, my name's Tony Dean. I'm the technical manager for Phoenix Contact UK. I have a varied background. Did 11 years in the Royal Navy as an electrical engineer. I worked for a couple of mainstream automation vendors. I've been with Phoenix Contact 8 years, and I'm the product manager for the PLC Next Technology range. And I also do a lot of the technical support for Phoenix Contact.
Cool.
Great stuff. Now, Pete, the reason you're joining us today is I was talking to you about PLCs, and I mentioned that this PLC Next you could code with Python, and you were quite interested from then on in, coming from your background of coding and electronics, etc. Yeah.
Absolutely. I mean, for me, I've seen lots of people using single board computers in industrial applications and in a single board computer environment. You know, coding languages like Python are very common. And when you told me about, when I think about PLCs, I think about these kind of very dirty industrial blocks that sit on a bin rail somewhere in a factory. And I don't, and I thought, wow, what? So, and when you said that you've got this kind of newfangled PLC that is almost behaves like a single board computer type environment, so somebody kind of from my background would be able to, pick this thing up and utilize it in an application. I thought, wow, this sounds really cool. So great to hear, from what Tony's got to say today, and yeah.
Okay, good stuff. Tony, so let's get to the name PLC Next. Is that a statement, or is that kind of marketing jargon? What's different about this type of PLC?
Okay, well, to be fair, it's quite an apt title because PLC Next, the next step in PLCs. I think it's commonly known that PLCs are programmed in a language called IEC 61131, and this has been the case since about 1996, and obviously the world has moved on since 1996. You only have to look at the technology with mobile phones. All of us have now got personal devices that we can actually customize to our own, to our own needs. But yet, automation has seemed stuck in this vacuum where IEC 61131 is king, and Phoenix Contact, in line with our name, Inspiring Innovations, we have come out with this brand new platform, which I'll be happy to go through some of the aspects, including why the name PLC Next. So what I'm going to do is I'll share my screen with you and show you a couple of slides of how to get the concept over to the unsuspecting public, as it were.
Okay.
So I'll share my screen. Just let me know when it's on there. Okay.
Yeah, can see.
So you can see my screen. So what I'm going to now do is I am going to start up a little presentation here. So PLC Next Technology, how can you best describe that to somebody? Well, I suppose one good way of putting it across is it's the reliability and robustness of the classical PLC world, with the openness and flexibility of a smart device. And as we go through, as I tell you more about this platform, you'll see exactly why we have come to that conclusion. If we move on. So essentially, this PLC or this platform will allow you to program in any of these mediums here. So from IEC 61131, we have MATLAB Simulink, which is how you simulate processes on a PLC before you actually connect it up to a plant, where you can do all of your models. We have onboard logging, but importantly now, you can write programs in C++, C#, and open source software. You can use Java, Python, and you can also, because the runtime sits on top of the Linux operating system, you have actually got access to the Linux features up into the runtime. And because of that, just like a smart device, you can download applications, apps, you can download function block libraries, you can download extension apps which work in conjunction with your program that you've written, or you can download an app which takes over the whole PLC and whatever modules you've got connected to it, depending on what the app is going to do. It takes it over as a whole entity, and therefore there's no programming to do. You just go onto the PLC Next App Store, which we'll be looking at later on. You download your app, you make sure that your PLC is configured in the way to suit the app, and you download the app as you would an app on your smartphone. And last but not least, it's cloud connectable to our Profit Cloud system out of the box. So out of the box is cloud connectable. On the hardware side, we can obviously connect to industrial networks such as Profinet. It can also be an Ethernet IP device. It can talk Modbus TCP, Modbus RTU, CAN bus, Interbus. So yeah, and basically what the ultimate goal is, as this particular slide shows, is that here we have a developer, traditional developer, looks a bit old and crusty, using IC61, 61131. And then we have other people around here, one person here using Visual Studio, one person here producing models on MATLAB Simulink, somebody working in Eclipse here, C++, another C++ program here, somebody using the software here. And also we have somebody working maybe in Java or Python, open source, onto the actual operating system. And then we've got our apps which we can download onto the platform.
So what I'm seeing here then, Tony, is you're not actually locking anybody in or out of using PLC Next. You know, like when maybe with traditional PLC, for example, you need to understand the programming language. You've got the high level programming here. That's very flexible.
Yes, exactly. And in the middle there, this represents the project that a company may be working on, but you can get people from all backgrounds, all different languages, to put together code which is going to be compiled on the actual PLC runtime, therefore making it all deterministic because it is compiled on one compiler. So also the PLC Next, it's not just a well, as I've just shown, it's not just a PLC with its own software package. It's an actual ecosystem, because as well as the hardware and the software, the PLC Next Engineer, you then have other things associated with it, like the PLC Next community, which we're going to go in. But as you can see, it's an ecosystem because any programming platform can join in.
That sounds cool. So when we look about, I guess, connectivity, you mentioned, I guess, about cloud connectivity and stuff, Tony. I think, you know, obviously with the rise of Industry 4.0 and companies trying to sort of, you know, make sure they're connecting their devices to the internet so they can collect data and scrape data and then analyze that. So, you know, are you able to, are you using common kind of things like MQTT, and can you use tools like Node-RED and all that kind of stuff to interact with it? If you, cool, okay.
Yeah, because on the as I mentioned before, the PLC has a cloud, it's cloud connectable out of the box. We have our own cloud system called Profit Cloud, and obviously if you've got a cloud system, you can use MQTT to either talk to a broker or pull data in from outside. So you can export data out via MQTT, or you can bring it in. Also, because we can now exploit the Linux operating system, you can use something like, you can load Docker onto the Linux operating system.
Yeah.
And then from there, you can then install Node-RED. And then from there, you can do whatever you want. I mean, you'll probably, I mean, I come from a traditional controls background. So all of this Node-RED and Docker and all this, all new to me. But I mean, you guys probably, you know, that's your world.
Yeah. Well, this is great. You think about transitions from, you know, again, we said earlier, single board computers. If you're a single board computer user, you're trying to put that into an industrial environment. They're not generally ruggedized for that type of environment. And then when you look at traditional PLCs, they're super expensive. And you are limited in the fact that, you know, from what I've learned about them, you know, you are limited to what you can do in terms of interacting with these things through different languages. And this, for me, seems like that fantastic stepping stone from, you know, your single board computer to, you know, a ruggedized, fit for purpose solution that will fit into that industrial environment, and you can talk to it in modern languages and code with it in an open source fashion and have collaboration with other engineers in this ecosystem you discussed. It sounds pretty cool to me.
Yeah. I mean, a lot of people have done some really clever and really powerful things with Raspberry Pis.
Yeah.
And, you know, you deploy them, you can deploy them. However, this is actually certified for use in industrial environments. Immune to shock, immune to EMC, it's all properly certified.
Yeah. And these things, right, they're running ARM processors, like a dual core ARM processor on that one, isn't there, I think?
Yeah, this one here, the 2152, has a dual core ARM processor, ARM processor with a dual core.
Yeah.
We have also an 1152, which is the little brother or sister to this one, and that has a single core. And obviously, both of those there at a price point.
Yeah.
Obviously, some applications, and the application I'm actually going to show today shows how you would use a dual core processor in order to segregate different parts of your program. But obviously, not every single PLC application requires that kind of power. So we have the 1152, so we can attack either end of the market.
Yeah. Okay.
So yeah, you kind of took the words out of my mouth there, Tony. My next question was going to be, can you detail any applications where PLCnext are being used, maybe outside of just what you would see in a traditional control environment within factories, etc.?
Yes, and in terms of, as I say on Blue Peter, I've got one that I prepared earlier.
Good man.
Just let me playing around with all these screens. Okay, I'm going to share my screen again. And then I'm going to start this application story. Okay, now this was an application. I was a moderator at SPS in Nuremberg last November, and there were 3 sessions, 2 German sessions, one in English, and I actually was one of the presenters in the English presentation. And if you want a full rundown of this, I actually did, or Phoenix Contact, we actually did an article on DesignSpark, and at the bottom of the article is the video of the presentation in Nuremberg. So anybody watching this who wants to catch up on, get the full story, as it were, obviously we're a bit limited for time here, you can go to the article on DesignSpark and watch the video. Okay, so here in this particular instance, the 2152 is used in order to solve a ecological problem as well as a safety issue. And this was done in conjunction with a company called, well, it's the Swiss Federal Railway, otherwise known as Schweizer Bundesbahnen. However, for this exercise, we'll stick to SBB. For obvious reasons. So the goal of this is for safe, sustainable travel. Now, as we all know, railways normally go through the countryside and all kinds of terrain, and obviously we have the issue whereby we have to keep the vegetation on railway lines and infrastructure. We have to manage it so that we have safe travel on the railways. And I'm sure we've all heard the term, you know, the 552 into Waterloo is delayed because of leaves on the line. Well,
yeah.
But obviously that I suppose that more or less shows why this kind of activity, you know, the control of the vegetation is required. And basically how it's done in this particular instance is that using the processor and its real-time capability, the train, it goes along the tracks and it actually sprays hot water onto the weeds, boiling hot water, which explodes the cells of the plants, and then it decays the DNA and the plants die. And that is how SBB have decided to do this, and they've done it for a number of reasons. So, as I explained, a hot water train is pretty much what it says on the tin, really. It's a train, it travels along the tracks, and it sprays boiling hot water onto the track infrastructure. However, as you can see here, there is no hose pipe attached to that train connecting it to a reservoir for an endless supply of water. So, and the track infrastructure of this particular railway totals to the distance from Europe to Beijing. So it's a bit of a, how much water could you carry on that train? How big would the train have to be? Obviously, some form of targeting has to be done. And this is where the PLC Next Technology 2152 comes into it. As the train goes along, the weeds are detected by some sensors. SBB call them weed seekers, but they are some specialized sensors which will take into account the size and position of the weed. That information is then passed up to the controller. The controller then does a calculation in terms of position for which valves to open, and then obviously where to open and when to open it, because this train is traveling at about 40 feet per second. So obviously you have to, as I said, there's a limited amount of water on the train, so you have to apply it just when needed.
Yeah.
And the reason why this calculation can be done and why it can is because the 2152 has a dual core. On one core is all the calculations are carried out, and on the other core, that's where the more mundane tasks are done. So you can create a fast task on one core, and then all of the other mundane normal tasks are done on the other core, which then means that the water is released, the boiling hot water is released at the right time when the nozzle is over the plant, not before, not after. And as I explained, it has to be real time, otherwise it's going to be an inefficient process.
Yeah,
that doesn't work.
Can't have any latency on that, can you, Tony?
No. So also, what does the future hold? How is this going to? Because if you think about it, this situation, it's a fairly arduous one. So how can we streamline it? Well, we can streamline it using our Profit Cloud. As the train goes along, it collects the information. And in the future, it is planned for the information to be collected on Profit Cloud, and basically the collection will be done via regional trains going about their everyday business. Now, this is a map of the infrastructure of the Swiss Railway. So as the trains are going about their everyday business, they'll be fitted with the weed seekers and the actual PLC. This information will be taken up, collected on Profit Cloud, and then transmitted to the SBB IT infrastructure. There'll also be other means of collecting information, drones, etc. And that will be put onto the SPB infrastructure. And then through using the openness of the PLC Next technology ecosystem, we can then share that information via MQTT with the company's infrastructure. Then what will happen is on an evening, on a night when the railway shut down, trains will then go out and target the weeds based on the information collected during the day by the regional trains and the other methods of data collection.
That's fantastic. Fantastic. Yeah.
Very cool.
So basically the issue or the aim is to keep the railway safe, but also a very powerful herbicide or weed killer, for want of a better word, is used. It's called glyphosate, and it is very, very potent. Now, as I've already said, how big the infrastructure of this company is, and this in the past is applied by hand on foot by operatives. So you're safeguarding the operatives because they're now not being exposed to this chemical. You're not dumping it all into the water table and into the local environment, and you're actually keeping the railway safe, which was the actual the primary issue here. But obviously we've been able to do the safety issue and an ecological issue as well.
I think one of the things that this highlights to me, Tony, it's not just that the PLC is performing a function, it's actually performing maintenance, and it's also your environment is given targeted information to the maintenance engineers for where the priority needs to be given.
Yes, yes.
So I guess, Tony, there'll be lots of users who are more akin to the traditional PLCs, the methods of programming and the application of those PLCs. What is it PLC Next can offer those guys? How would you either convince them to take a look at PLC Next, and what are the benefits that they would get moving across to PLC Next?
Okay. Well, for starters, I think it's widely acknowledged that people who are IEC 61131 proficient at a premium, or they're becoming at a premium. So basically what it's going to be able to do is, if you're the principal of a systems integrator, or you're a principal at a machine builder, you're now going to be able to diversify the intellectual capabilities of your workforce while still maintaining your core business. Because a lot of tasks done in 61131, if you do them in C+ or C# or Python, a few lines of code could take the place of a swath of function block diagram or ladder. Yeah. So only that, you're going to be able to keep your consistency, because you can actually still have people working on parts of the code, but then you can have people with high-level language experience writing code in Eclipse or Visual Studio or in Python, and then how it works is you import those as a library into your into the programming editor, PLC Next Engineer, and then just run that library as a POU, as we call it in IEC 61131. Just run it as a program in a task, and you can mix tasks as well. So you can have a task written in C, a task written in IEC, a task written in Python, all running in the same task.
Cool. Yeah.
Yeah. Yeah. I get that. The generation coming up behind us, they're into their code. Obviously, Pete, you're into Python and code, and so what they're learning in terms of code and practice at the moment in schools, college, and university, moving forward, that's going to be the predominant thing that these guys are used to. Like you say, the old guys are becoming the premium. At some point, there will be that tipping point.
Yeah, and it's a case of future proofing. You know, future-proofing your business while maintaining your consistency of the delivery of your product.
Yeah, hadn't thought about that. Yeah, good.
Yeah, yeah. Okay, so I mean that's interesting. I mean that kind of leads me to think about, you know, the whole sort of PLC Next environment you mentioned earlier, Tony, which sounds quite exciting. This ecosystem, and I mean, I guess obviously you guys are in for this for the long haul, right? PLC Next is something that's going to be here, you know, for the foreseeable future at least, and as a platform. But how, you know, in terms of, you know, let's talk a bit about all this support and ecosystem you spoke about before, where you showed us where people can get code and share stuff. So yeah, show us a little bit about that. So if I was getting into this, how would I, you know, start interacting with the product and get questions answered that I needed and find out information, all that kind of thing?
Well, as I mentioned at the beginning, this is not just a PLC with a programming package. It is actually an ecosystem, and so far I've talked about the functionality of the actual processor, some of the aspects of the hardware, but now we come to the other part of the ecosystem, which is what have we done in the background? What have we done to support this? What kind of support is there going to be in the future?
Yeah.
And I think a good place to start is the PLC Next community. And I'm on the lead page of the PLC Next community here. And when I go through what we've done, you'll see that there is a massive amount of work that's gone on in the background to make sure that the support is there, not just on the end of a phone, as you normally get with a PLC vendor where you have to phone up a helpline and all the rest of it. But here we have an actual community that is being contributed to by normal people, not just people who work for Phoenix Contact.
Yeah.
But what I'll do is I'll start off with the lead page of the actual community, and the first page I'll go to here, we have news. So we have you know, it's there, it's telling people that okay, the PLC Next store was down between Monday the 12th, and it was temporarily shut down because it needs to be updated. We've also got news about our recent tie-up with Yaskawa, which gives us now a platform for PLC Next with motion control. Yaskawa being one of the foremost producers of motion, etc., etc. Stuff about online documentation. PLC Next CLI goes open source. Bit about the Profit Cloud there. The Business Lounge, and this particular article in the Business Lounge, this is another part of the actual community, by the way. But open source and industrial automation, we were just talking about that is the main driving force behind this platform. And in this particular article, I'm not going to go all the way through it, but it's saying here, modern programming languages and the need of experts.
Yeah.
And this, when you read more about in this article, it actually tells you about what we talked about earlier about the not the demise, but the fact that, you know, 61131 is not being rapidly taught in technical colleges. It's all the higher level languages, and people coming through today, they understand the apps, they understand C++, coding, as it were, and it's trendy to code. So the way of PLC Next and Phoenix Contact getting down with the kids by inviting them in to bring their coding skills to PLC Next.
So I guess that means you're obviously utilising things like GitHub.
We actually have. Yeah, we actually have a. If I go onto the GitHub, so here we go.
Oh, okay, yeah.
And you can see here Docker getting started. Docker, we use Berliner Engine actually, which is a similar thing, which allows you to PLC Next CLIs, and again.
Okay, so a whole load of repositories and things there. That's
correct.
Cool. Yeah,
correct. And all this has been, we put some stuff on here, but obviously we have users and people out there in the coding world who are actually contributing to it. We also have a YouTube channel which has literally dozens and dozens and dozens.
There's quite a lot there, Tony. Yeah.
Yes.
Wow. Fantastic.
A lot of when this first came out, me working for for Phoenix Contact as somebody who was dealing in the automation, and this product was launched, and obviously it was launched in Germany, and I'm asking them, oh, when are you going to win it? And it was more or less they were going, look, yes, we're gonna. And what was happening was there was this build up of this material in the background, because there's no point launching something as revolutionary as this and not having the substance behind it, because you'd just be setting yourself up for a fall, really.
Okay. I mean, I think this is where communities are so important, isn't it? Because your community can help you build all of this amazing content around applications and share the code that they've done and tell their application stories, and this is really cool. Yeah.
I do think that's a point that a lot of manufacturers do overlook to their cost, Tony, is that they launch product without a lot of detailed support. What you're showing me here is that, and what I can see is they make sure that this is right before they really start to push the product, that you have a place where users can come to, talk to each other, get information, even develop apps, maybe for future sale or whatever. Yeah.
See, this is where you're so more aligned again to the single board computer world, right? Because that's kind of how that happens over there, right? So this is, for me, you can see easily the migration of getting into this environment, stepping across from, what you're used to in that SBC world. So yeah, it's just
correct. I mean, if you look here, we have a maker's blog. How there are dozens and dozens again of examples.
Yeah.
Things. We also have a knowledge base where we have webinars, free webinars for things like how to install the Berliner engine onto the Linux operating system. We have tutorials. We have e-learning, PLC technology basics, how to program the HTML5 web-based HMI that is actually on the actual controller.
Yeah.
Features and roadmap, what's coming in the future. And last but not least, we have a forum where people have had issues and what have you, and people have found fixes for them. So again, the community can swap ideas, very much like the open source community.
Yeah.
Really.
Yeah.
And that is what we're aiming for. So yeah, in terms of what is a life cycle commitment? Well, I think we've just shown there how committed we are.
Absolutely.
For this platform to grow. Yeah. And now you can see my face again.
Always a pleasure. So you were talking about the kit there. Have you got one that you can show us, a complete kit?
Yeah. This one here, this one's the first starter kit that we put out. And to be fair, the price point wasn't really set at an attractive level, so that because as we all know, people in the open source community, they're used to being able to get something from wherever. Not going to mention any names.
Tony, are you able to pick that up? Because I don't think we can quite see it.
Sorry.
Yeah.
Okay, yeah. It's plugged in and it's connected to it. Can you see that?
Yeah.
It's actually working, because in my setup here, this is actually sending information up to my cloud, and it's also running some interbus over there via a little proxy I've got here. But yeah, this is the older one. It's, as I say, it's a 2152, and it has the traditional axial line I/O, 8 in, 8 out, and 2 analog in, 2 analog out. It's got a potentiometer here and 8 switches, so you can get inputs onto the 8 inputs. So that's that one. And this one was the price point for this was quite high, really. And so what we've done is we've gone, because we're a company that like to collect data and then make changes. That's how you improve. So this is the latest one. It's also plugged in, but it's not actually doing anything. I'm actually halfway through a free online course on that we run for people who take up our platform. I'm doing at the moment, which is going to run for about another 3 weeks, and then I'll be, if anyone's interested, get in touch, and I'll let you know when the next course is going to be. Anyway, a little quick advert there for Phoenix Contact. I'm sure you don't mind, guys. But this is a far more sexier looking setup here, and we're actually taking advantage of using our compact smart elements IO as opposed to the more bulky axial line IO. Oh, yeah. It's axial line smart elements. I'm getting myself into a right mess here. There you go. So yeah, and this one comes in. This features 4 inputs on these switches here, and a slider for the analog. So you can go on there and do a little project. Yeah. You can, anything you can do with a Raspberry Pi or whatever, you can do with this, because you can log onto here with a root password for the Linux, and then you do what you want. I think it's Ubuntu that's on here. But again, yeah, sounds like I'm an expert. I am an expert, but not on that side of things.
Yeah. So Linux desktop basically.
I'm learning. Yeah. But yeah. As I said, on here we're featuring our new axial line IO on this particular kit, and this is in 15mm here. You can have 15mm strip. You can have 32 IO. It's a 16 IO card. I'd like to say that if automation was Goldilocks and the 3 Bears, this would be the baby bear's bowl of porridge. It's just right. That's one for the kids.
Fantastic.
Cool. But yeah, so yeah, as I've shown you all of this, all of these features, and it is truly an ecosystem. It's not just, oh, here's our new PLC, see how you get on with it. And incidentally as well, something I forgot to mention, very remiss of me, PLC Next Engineer is totally free of charge. So the programming software, the full IEC 61131 programming package, where if you go to our competitors, you're paying anything from £800 to £1,500 for the software. And top of that, you've then got upgrades every year and service.
Yeah, yeah.
So we're doing our best now to give people the chance to embrace the future with PLC Next Technology.
Very cool. Good.
That's been a great review, Tony. You not only shown us the product, the application, the support network, the environment, plus all of the benefits and sort of like the cost implications. It also just the level of detail that you've gone into today. It's been fantastic. I think what we'll do, we'll also put some of the links below this video in the article. So we'll link to the community, and we'll also put some of the links into your other videos, particularly the article you did on DesignSpark. For us, what's next is we are going to get one of these kits, and we are going to send it to one of our technical bloggers who's going to look to include it in a project, and we'll bring you all the updates on that, Tony.
This has got your name on it. And also, when your technical blogger, if he comes back on with it, I'd be very much interested in maybe you know, coming on and swapping some experience.
Yeah, absolutely. Absolutely. Brilliant. Thanks, Tony. That's great. Thank you.
Thank you very much, guys. It's been a pleasure.
Okay.